Okay, our next method for solving systems using matrices it is called Gaussian elimination, and it involves an augmented matrix. So an augmented matrix, by definition, to start out with, of a system of linear equations uses simply the coefficients and the constants. And we're going to write it here in a standard form. So our augmented matrix, I'm going to write it with just the coefficients, 2, -7, and 1, just like we did our coefficient matrix before. 1, 5, -8, -1, 4, and 3. And then you also include, and I like to draw a line right here, the constants. That line is kind of like my equal sign. And this is an augmented matrix. A system in row-echelon form, or triangular form is sometimes called, when the last equation contains just one variable. Each equation above it, each equation above contains the variables below and one additional. And the leading coefficient of each equation is 1. So given the corresponding, give the corresponding augmented matrix of this is in row echelon form. So look, we've got, if we were to write that in as an augmented matrix, we'd have 1, -2, 5, and then our constant. Then we'd have a 0 because there's no x's, 1, -6, and a 26. 0, 0, 1, and a -3. So why do we call this row echelon form? Well, again, from the definition, here's what you've got to look out for. All of your leading coefficients for x, y, and z are 1s, or pretty much that means you have 1s on your main diagonal. And then everything below it has to be 0. So in the last row here, you have only one variable left, and that's the z. And that's what you see here. Z is -3. And here you have just the one y with one additional variable, which again just so happens to be the other z. And then above it, you have the x, and then the y and the z in addition. Row echelon form is convenient because the remaining variables can be solved for back substitution because we know what z is. So therefore, now that we know what z is, you could go back and plug that in for z into this one, and you can figure out what y is. And then now that you know what y and z are, you can plug it back into this one, and you now know what x is. So that's called back substitution. Next up, elementary row operations. How do we get it in that form? And this is how we're going to use these row operations. The following operations, called elementary row operations, produce equivalent systems and can be applied to an augmented matrix to transform it into that form. So here's your operations that you can do. Operation number 1, you can flip any 2 rows. You can exchange 2 rows. Operation number 2 that you can do, you can multiply a row by a non-zero constant. So if you have a 1/8 and you need a 1, you can multiply by 8. So you can multiply any row by any number you want to as long as it's not 0. And then the third and last, the one that we're going to use the most, we can add a multiple of one row to another row. And that's going to change the row that we add it to. So here we go, Gaussian elimination. The following process of solving a system of equations is known as Gaussian elimination, named after German mathematician Carl Friedrich Gauss. Number 1, write the system as an augmented matrix. Number 2, transform it to row echelon form using these elementary row operations. Number 3, use the row echelon form to rewrite it back as a system, and then we're going to use back substitution to solve. Let's try one of these, and these are going to take a little while to get used to. They're not easy. So step number 1, let's write it as a coefficient, or not as a coefficient matrix. Let's write it as an augmented matrix. So we have a 1, a 2, a -9, and the -59. You have no x's. You have 1 y and 4 z's, and that's equal to 12. And then you have 1, -1, 3, and 25. So this is actually nearly in the form that you want it in, okay? So your 3 rules is you can multiply any row by any number you want to. You can flip-flop 2 rows, like if you want to switch these 2 rows, you can. And then the third and final rule is you can add any multiple of one row to another row, and that's going to change the row that you add it to. So again, what we're wanting is we're wanting a 1 on our main diagonals. We have a 1 here and we have a 1 here. We're in good shape there. However, in our third one, we don't have that 1 yet. So here's the steps that I like to take. Step number 1, I always make this a 1. Whatever it takes, we make that a 1. And then I use that 1 to make this a 0, which I'm good, and to make this a 0. Now, how do you make that last one a 0? Here's what you do. I've got to multiply. I use this as kind of like a tool. I'm going to multiply this row by something so that when I add it to this row, it makes it a 0 like I want. So what can I multiply, or what do I need to add to this to make it a 0? And that's -1. So what do I multiply this by to give me a -1? And -1 times that 1 would be a -1. So here's what I'm going to do. I'm going to multiply my first row by -1. And I'm going to add it to row 3. Now, when you do this process, this only changes this row. So my first row does not change. So I'm going to leave it as 1, 2, -9, and -59. And I'm not even touching my second row yet, 0, 1, 4, and 12. So the only thing that's going to change is my row 3. So I'm going to do -1 times this, and I'm going to add it to row 3, and that gives me a 0. If you do it to one piece, you have to do it to everything in that row. So I've also got to multiply this by -1 and add it to this. That'll be -2 and -1, which is -3. I've also got to multiply this by -1 and add it to this. That'll be 9 and 3, which gives you 12. You also have to multiply this by -1 and add it to this. That's 59 and 25, which gives you 84. So now I've got the 100 like I like it. Now what do I do next? I go to my next column and I make sure that this is a 1. And then I use that to make anything below it a 0. So let's do that now. And how am I going to do it? I ask myself, what am I going to have to multiply, or what do I have to add to this to make it 0? And that'd be a 3. So what I'm going to do is I'm going to use this tool right here, and I'm going to multiply it by that number. I'm going to do 3 times that row, which is row 2, and I'm going to add that to my row 3. And again, that only changes this. Now you have to do it to the entire row, so even those numbers that we just changed, you've got to do it to them too. So my first row, I'm not touching. So I still have that. My second row does not change. I'm using it to change my third row, but my second row does not change. So here's what I'm doing. I'm going to multiply this by 3, and I've got to add it to that. Well, it's still 0. And that's the reason, it's kind of like working a Rubik's Cube. That's the reason I'm going in the order that I do, is to make sure that I don't change anything that I've already got like I like it. Now I've got to multiply this by 3 and add it to that, and that gave me my 0 that I needed. Multiply this by 3 and add it to that. That's 12 and 12, which is 24. And then multiply this by 3 is 36, and add it to that gives me 120. Now I'm nearly done. The only thing that is left, I have my 1, my 0, my 0. I have my 1 here and my 0 here. I just need this to be a 1. So that comes, one of my other rules is I can multiply anything I want to times a row to change it. So I'm going to take that in order to make this a 1. I'm going to do 1 over 24 times row 3. And that's going to change that into a 1. So my row 1 and 2 does not change. The only thing that's going to change is this third row. This 0 does not change when you multiply. This 0 does not change. That'd be problems if it did. 1/24 times 24 is 1, and 1/24 times 120 is 5. So now we have it like we like it. We're going to change. We have our 1s on our main diagonal. We have 0s below it. Write this back as a system of equations, and this is what it's going to look like. And from that, you can kind of see why they call it a triangular matrix. So we know what z is. So come right here and plug that in. And that gives me y plus 20 equals 12. So we now know what y is. That would be a -8. And now that you know what y and z is, you can now plug it into the first, and that would be x minus 16 minus 45 equals -59. And that tells me that my x value is going to be 2. So therefore, my x is 2, y is -8, and z is 5. That's your solution. Let's try it again. Step number 1, write this as an augmented matrix. Okay, now I always start in my top left-hand corner and make sure that this is a 1. If it's not a 1, then multiply that whole row by something to make it a 1. Or if let's say that this was a 5 or something, we'll just flip-flop some rows and make that a 1. Whatever it takes, whichever one of those methods would work best, just make that a 1. Okay, now that I know that it's a 1, now I need to change everything below it to a 0. So I'm going to multiply this times something so that when I add it to this, it becomes a 0. And I'm going to write it out here next to row 2 because that's what I'm going to change. I'm going to multiply -1 times row 1, and I'm going to add that to my row 2. That will not change row 1. It will not change row 3. It is only going to change row 2. So let's leave the other two the same. So now, -1 times row 1, -1 times this, add it to this, gives me a 0. -1 times this is 1, add it to this, gives me a 2. Notice it's only changed my second row. -1 times 4 is -4, added to this is -6. -1 times 6 is -6, added to this is -20. Now we're going to do the exact same process to turn this into a 0. I'm going to use, again, this 1 right here. I'm going to multiply everything in row 1 again by -1, and I'm going to now add it to row 3. That's only going to change row 3. So therefore, let's recopy row 1 and 2. They stay the same. And now I'm doing -1 times row 1 and add it to row 3. So -1 plus 1 is 0, which is what I need. Multiply by -1 gives me 1 plus 2, which is 3. -4 plus 5, which is 1. -6 plus 6, which is 0. So my first column is done. Let's move on to our second column. Second column, now what I do is I make this a 1. I want 1s on my main diagonal. So therefore, in order to make that a 1, I can multiply the entire row by 1/2. So I'm simply going to do 1/2 times row 2. Doesn't change row 1 or row 3, so let's recopy them. And then simply multiply the entire row 2 by 1/2. Notice this does not change. If it changed, that would be problems. That's a 1, a -3, and a -10. Okay, now use that 1, and anything below it, we're going to make it a 0. So the way we're going to do that, I'm going to multiply this 1, that's my tool. I'm going to multiply it by some number so that when I add it to this, that gives me 0, and that's going to be a -3. And I'm trying to change row 3, so I'm going to put my rule out here next to row 3. I'm going to do -3 times my tool in row 2. I'm going to add that to my row 3. And that only changes this row, row 3. So rows 1 and 2 stay the same, so I'm going to recopy them. And now let's do our steps. -3 times this and add it to this. It's still 0. -3 times this and add it to this. It's still, or it's 0 now. -3 times this is 9, plus 1 is 10. -3 times -10 is 30, plus 0 is 30. Okay, my last step now. I've got my 1s, my 0s below it. I just need to make this a 1. And it's pretty easy how to do that. We're simply going to do 1/10 or divide it by 10. We're going to do 1/10 of row 3. So rows 1 and 2 stay the same. And then row 3, multiply everything by a 10th, gives you 0, 0, 1, and 3. So now I'm finished with with row echelon form. So let's go ahead and write that back as a system. And we now just simply use back substitution. Since z is 3, plug it in here. That tells you that y is equal to -1. And since z is 3 and y is -1, plug it in here and here, and that tells me that x is equal to -7. So therefore, my solution is -7, -1, and 3. Let's do another example. Example number 3. Step number 1, write it as an augmented matrix. And again, my steps are always the same. Make this a 1, 0 these out. Make this a 1, 0 this out, and then make this a 1. I always go by those steps every time, and it always falls out just right. So how do I make this a 1? Well, the entire row is multiples of 4. So therefore, what I do is just do a fourth of it. Now, you could flip-flop. That's something we haven't done. You could interchange those two rows as also an option. So either, I'll tell you what, since we haven't done that yet, let's just do that. Let's flip-flop our first row and our second row and rewrite this thing. So I'm going to do row 1 flip-flops with row 2. Now here's my new matrix. Okay, next up, I need to make this a 0. So if I add -4 to it, that'll be a 0. So use the tool, multiply it by -4, so -4 times row 1, and we're going to add it to row 2. Again, row 1 and row 3 does not change here, so let's go ahead and copy those down. And now let's go through our steps. -4 times this and add it to this gives me 0. -4 times this is 8, added to that gives me a 4. -4 times this is -4, added to that gives me a 4. -4 times this is -44, added to this gives me -32. So now I've got a 1 and a 0. Now I need to make this a 0. So if I add 1 to that, it makes it a 0. So I'm pretty much going to multiply my first row by 1, which is not going to change it, and I'm going to add it to row 3. And that's again going to change row 3. So 1 and 2 stays the same. So let's copy them down. And now let's go through our steps. 1 times this added to this is 0. 1 times this added to this is -1. 1 times this is 1, added to this is -2. 1 times 11 is 11, added to this is 10. So now my first column is finished. Now let's move on to our second column. I need to turn this into a 1. Very easy because everything's a multiple of 4. So all I'm going to do is 1/4 of row 2, and that's going to make it a 1. Rows 1 and 3 stay the same. And when you do 1/4 of row 2, you have 0, 1, 1, and -8. Again, we now move over, stay with that second column, and we're now going to use that to make this a 0. So what can I add to this to make it 0? And that's a 1. So we're going to do 1 times row 2. We're going to add it to row 3, and that only changes row 3. So let's go ahead and recopy row 1 and 2, and let's change row 3. Multiply by 1, add it to this is still 0. Multiply by 1, add it to this is 0. Multiply this by 1, add it to this gives me -1. Multiply this by 1 is -8. Add it to 10 gives me a 2. So we're nearly finished. The only thing is now our third row, we need this to be a +1. And we can very easily change that by simply multiplying them both by -1. And instead of recopying it, I'm just going to change it. Multiply this by -1 makes it a +1, and that makes this a -2. Okay, now we can go ahead and write that back as a system so that we can use back substitution. So since z is -2, plug it in here, and that gives you that y is -6. And since that y is -6 and z is -2, plug it in there and there, and that tells you that x is equal to 1. So therefore, my solution is 1, -6, -2. Example 4. Step number 1, write it as an augmented matrix. Okay, step 1, I need this to be a 1. So a couple of different ways you could do that. You could multiply this whole row by -1, and then you could interchange the two. Or I'm just going to go ahead and do 1/3 the entire first row. The reason I'm going to do that is I notice the entire row is all multiples of 3, so I don't have any fractions there. So rows 2 and 3 stay the same, and row 1 turns into 1, 2, -4, and -14 when you take a third of it. Again, we are now going to use that to make this a 0. So you ask, what can I add to -1 to make it 0? And that'd be a +1. So I'm going to do +1 times row 1. I'm going to add it to row 2. That's only going to change row 2. So rows 1 and 3 stay the same. And now let's change row 2. Multiply by 1, add it to this, gives me a 0. Multiply by 1, add it to this, gives me a 1. Multiply by 1 is -4, add it to this, gives me -2. Multiply by 1 is -14, add it to 9, gives me -5. So next up, now we're wanting to make this a 0. So follow the same procedure. Multiply your tool by something and add it to it. I need to add -2 to this. So I'm going to do -2 times my row 1, 1. I'm going to add it to row 3. And that's only going to change row 3. So let's recopy 1 and 2. And now let's change row 3. Multiply by -2 and add it to this gives me 0. Multiply by -2 is -4. Add it to this is -3. Multiply by -2 is 8. Add it to 4 gives me 12. Multiply by -2 is 28. And 29 is 57. Okay, next step, we've already got a 1 here. That would normally be our next step, so we can skip on and to the next one. I need to make anything below it a 0. So what can I add to negative 3 to make it 0? That'd be a positive 3. So I'm going to multiply my tool in row 2 by positive 3, and I'm going to add it to row 3. That does not change rows 1 or 2, but only row 3. So let's go ahead and do 3 times this, add it to this, it doesn't change it. 3 times this, add it to this, makes it a 0. 3 times this is negative 6, add it to this, gives you a positive 6. 3 times this is negative 15, add it to this, gives you a 42. And now we're on our last step. To make this a 1, I simply have to do 1/6 row 3. So rows 1 and 2 doesn't change. And when I do 1/6 of row 3, I have now a 0 still, a 1, and a 7. So now we're ready for back substitution. So write that back as a system of equations. And you have, since z is equal to 7, plug it back in, and that gives you that y has a value of 9. Plug that back in, and that tells you that x has a value of negative 4. So therefore my solution is negative 4, 9, 7. The next one, example 5. Step number 1, again, write it as an augmented matrix. I'm going to go ahead and swap row 1 with row 2, just to where I don't have to multiply by anything to get that 1 up top. Row 3 doesn't change, but I'm going to swap the other 2. Okay, now I'm going to use this tool, and I'm going to make everything below it a 0. So let's start with a 2. In order to make a 2 into a 0, you're going to have to add a negative 2. So I'm going to do negative 2 times my first row, and I'm going to add it to my second row. That's only going to change the second row, so 1s and 3, my first and third row stays the same. And let's perform the operation on my second row. Multiply by negative 2, add it to this, gives me 0. Multiply by negative 2 is 4, add it to this, gives me negative 4. Multiply by negative 2 is negative 2, add it to this, gives me negative 8. Multiply by negative 2 is 38, add it to 10, gives me 48. Okay, now let's make this a 0. So I need to add a negative 1 to it to make it 0. So I'm going to do negative 1, and notice I'm putting it next to the row I'm trying to change. Negative 1 times my tool in row 1. And again, I call this 1 my tool, and I'm going to add it to row 3. So therefore, rows 1 and 2 does not change. And let's perform the operation on row 3. Multiply by negative 1, add it to this. Multiply by negative 1 gives you 2, add it to this. Multiply by negative 1 gives you negative 1, add it to this is negative 5. Multiply by negative 1 is 19, add it to 25 gives you 44. Okay, so now look what you have left. You've got the 1, 0, 0, and the next question is, how am I going to get a 1 right here? Well, there's a couple of options. Since you already have a 1 here, and interchanging those two will not affect these zeros. Now, that's something important to look at. Let's just go ahead and swap row 2 with row 3. Row 1 stays the same, and here's what your system now looks like. So we now have our 1 where we want it, and let's use that 1 to make this a 0. So I need to add a 4 to it to make it a 0, so I want to change my third row. So we're going to do 4 times my tool in row 2, and we're going to add it to row 3. Does not change row 1 or 2, so let's copy them down. And now let's perform our operations. 4 times this, add it to this. 4 times this, add it to this. 4 times this, add it to this is negative 28. 4 times 44 is 156. Add it to 48, and you get 204. Actually, that's supposed to be 224. There we go. Okay, last step, I need to now make this a 1. And that's pretty straightforward how you do that. You're simply going to multiply by its reciprocal. So we're going to do negative 1/28 times row 3. So rows 1 and 2 do not change. And your last row turns into 0, 0, positive 1, and negative 8. Now let's go ahead and write that back as a system. And that's going to tell us our answers. Since z is negative 8, go back and plug that in. And that tells you that y is going to equal 4. Plug both of those back in, and that tells you that x is going to equal negative 3. So my solution is going to be negative 3, positive 4, and negative 8. Example number 6. So let's write it as an augmented matrix. And you've got a couple of different ways to get the positive 1 in the top left-hand corner. Now, one method would be is just multiply everything by -1, and instead of having to rewrite that down again, you can just go through and do that. That makes this positive, make this positive. This will now be negative, and that'd be negative. So you don't actually have to show that step. For me, you can just change those. Now let's make this 1. Let's use it as a tool, and let's use it to zero this out. And the way we're going to do that, we need to add -1 to it. So we're going to do -1 times our tool. We're going to add it to row 2. So rows 1 and 3 do not change. And let's perform the operation on row 2. Multiply by -1 and add it. Multiply by -1 and add it. Multiply by -1 and add it. And multiply by -1 and add it gives you a 60. We now need to zero out this number. So we need to add -2 to it to zero out. So let's do -2 times our first row, and let's add it to our third row. Rows 1 and 2 do not change. And now let's perform our operation on the third row. Multiply by -2 and add. Multiply by -2 and add. That's -12 and 3, which is -9. Multiply by -2, that's 4, and add gives you 3. Multiply by -2 is 56, and -5 is 51. Next step, we always want to make, let me change colors. We want to make this a 1. Now, it looks like we're going to end up with some fractions here. If we do -1/10, we're going to end up with a fraction right there. But we would have fractions here if we did it as well. So let's go ahead and let's do -1/10, row 2. So rows 1 and 3 will stay the same. And row 2 turns into 0, 1, which we want, -1/2, which might be a little bit of more trouble, and then a -6. So next step, we're now going to use that to zero this out. So to zero it out, we need to add 9 to it. So we're going to do 9 times the tool in row 2, and we're going to add it to row 3. So that leaves rows 1 and 2 the same. And now let's change row 3. So we're going to multiply by 9 and add it. So that's going to be a 0. Multiply by 9 and add it. It's a 0. Multiply by 9 gives you -9/2, and we've got to add that to 3. Common denominator, it's going to be 2. So multiply top and bottom by 2 will be a 6/2. So that's going to be a -3/2. Multiply by 9 and add it gives you -54. And 51 gives you -3. Okay, last step, we need to make this a 1. So let's multiply by its reciprocal. So let's do -2/3 times row 3. Rows 1 and 2 stay the same. And row 3 turns into 0, 0, 1. And when you do -3 times -2/3, that gives you a +2. So now let's write it back as a system. And when you solve it, you get z is 2. Plug it back in, so therefore your y value would be -5. And when you plug those back in, that gives you an x value of 6. So therefore your solution would be 6, -5, and 2.